All right, in the last little video, we looked at the perpendicular bisectors of a triangle, okay? Now we're going to look at the angle bisectors of a triangle, okay? So we're going to be looking at those angle bisectors, okay? So we're going to be looking at the angle bisectors of this triangle. Okay, so what we're going to do is we're going to come in and we're going to bisect each of these angles. There's 3 angles in each triangle, so we're going to come in and we're going to bisect each of those angles and see what happens. So let's start here with angle A. GeoGebra makes life a little easy for us. It actually has an angle bisector option. Angle bisector, it says select 3 points or 2 lines. Okay, so I want to bisect between this side and this side. So there it goes. If you notice, it gives me this other one here. Okay, if we were to, instead of doing it based on the 2 lines, if we were just to go from C to A to B, it'll only give us that one. Okay, so here we have this angle bisector. So as we move this triangle and change that angle, it's always going to stay and go through the exact middle of that angle. So it basically creates 2 congruent angles. So I have 2 congruent angles. This one here, this angle, and this angle are congruent. Okay, so there's the angle bisector of angle A. Okay, let's go ahead and let's do the angle bisector of over here angle C. So we'll go B, C, to A. There's the angle bisector here. If you notice, these 2 angle bisectors intersect here at, let's go, point D. So they intersect there at point D. And as I change these angles, again, those always stay as the angle bisector and at that point D. Okay. All right, and so let's do one more angle bisector. Okay, we've got this angle yet. Okay. Okay. If you notice, all 3 of these angle bisectors intersect at point D. So we call point D that point of concurrency. It's the point of concurrency of the angle bisectors. We actually have a special name for that point of concurrency. We call it the incenter. Just like we had the circumcenter for the perpendicular bisectors, the angle bisectors all intersect at the incenter. Okay? And what's interesting about this incenter is if I find the distance between this point and each of these sides, so we go to that side. So the distance from point D to side C is 2.08. Okay. And if we go the distance from point D to side B, it's 2.08. And point D to side A, it's 2.08. Okay. But again, what GeoGebra is measuring there is it's measuring that perpendicular distance. Okay. So it's measuring the perpendicular from D to that side. So it's measuring here. Let me move these points a little bit so you can, so that perpendicular gets a little separate of it. It's measuring this perpendicular distance right here. Okay, so here from D to this point here, D to E, it's measuring this perpendicular distance. So this is a 90. Okay. Because to measure the distance from a point to a line, it has to be that perpendicular distance. So what we've noticed here then is this point of concurrency of the angle bisectors, which we call the incenter, okay, is equidistant from the sides of a triangle.